Here is the Gliese 433 system. I'm not too sure if I'm pronouncing that the right way, but there it is. We have found three objects, which I'm going to overview in this system. You have Gliese 433, that's a red dwarf. It's an M-class spectrum star, sits right there. You have a gray dwarf, 433 Charlie. It's about 55 times the mass of the Earth. It's sitting at about right there. Jupiter would be down here. And then you have 433 Bravo, which is a blue dwarf. It's about 9 times the mass of Earth. It's sitting at about right here. And then obviously you have Earth down here, Mercury and Mars, all that stuff down there. Those are, dead stars. According to the theory of stellar metamorphosis, you have large, bright stars up here, and they cool and shrink, and the ionized material becomes gaseous, and it begins the differentiation process as it cools and dies. So what we have here is a very, well, not a very young, I would say older than the Sun star, Gliese 433, and you have an intermediate age star, the gray dwarf, 433 Charlie. We'll just call him Charlie right there. It's in what I like to call the gray area. I didn't call it a gray dwarf because of the physical characteristics of the star. I just called it a gray dwarf because it's in that gray area where the spectrum stops and the star cools to the point where astronomers call them planets, and we all know that's incorrect. A planet is an evolving star. And then you have 433 Bravo. We'll call him Bravo. He sits at about here. So he's a much more evolved Jupiter gaseous object. Now, a few predictions can be made concerning these three objects. I'm not going to go over the red dwarf. I'm not going to go over the gray dwarf. I would just imagine it to be a bit larger than Jupiter, maybe brown in color, and having a larger radiative belt than Jupiter does. What interests me more is the blue dwarf. According to this theory, it should have deep water oceans covered by a thick methane atmosphere. So the atmosphere will be thicker than Neptune, and it will have much more developed water oceans in its interior, which facilitate the formation of the crust, obviously because it's a much younger Earth, but obviously older than the Jupiter, the gray dwarf, Charlie, and red dwarfs in earlier stages of evolution. What's really fascinating to me is the possibility of this object having its own moons, and this object possibly having a moon or two. But those would be obviously maybe large asteroids or moons like Ganymede, Io, or various other objects. Think of the movie Avatar, where you have Pandora orbiting a gas giant. You could have a Pandora orbiting Charlie, or you could have a Pandora orbiting Bravo, because there's a lot of objects to choose out of which would mix in with that. But basically there you have it. For those who are new to these talks, the main theory is that you have stars that cool and die, and they become older, rocky stars with differentiated interiors and iron cores. And the essence of planet formation is the fact that it has always been stellar evolution. The star is the young planet, and the planet is the old star. In other words, you can age stars like this. You would have, this marker isn't working. You would have the youngest up here, and you have your oldest down here. And according to basic thermodynamics, the object would always lose enthalpy, and it would cool and shrink and die, after obviously it was born somewhere up here, or a variation of this theory where the star is born as a white dwarf, then it moves upwards, expands to its maximum extent, and then it starts cooling and collapsing over many billions of years, forming what's called the planet. But there's the Gliese 433 system. We should find deep water oceans on that star right there.